Welcome to 9.4 circuit types. So, before I begin, I just want to tell you that I'm going to probably break this up into two separate videos because the problems or the practice problems that we're going to go through, I'm going to take a little bit of time in order to go through. So, I'll label it like 9.4a, 9.4b, but it's all physics lesson 9.4 circuit types. And those of you who are not blessed to know, this is Short Circuit from the film Short Circuit. He looks exactly like Wall-E. Makes you wonder. Okay, Disney, it makes you wonder. Anyways, all right. Let's talk about circuit types. So there's two basic types. We call the first one a series circuit. This is what we've been previously calling simply a simple circuit, right? Series. Second one over here, what we have is a parallel circuit or a more complex circuit. Now the way to tell the difference between the two is with a series circuit, only one way to go. With a parallel circuit, it can go this way or it can go this way. Come back. So more ways to go. And that's helpful because if there's a break, I don't know, here, like this bulb burns out, then the electricity can just keep going that way. And everyone's happy. And you don't have to check every single light bulb when the Christmas lights go out. Who would have thought? Alrighty then. Let's talk about series circuit first. This one is the easiest of the two. And we've already kind of started going through this. So voltage on the battery is the sum of all the voltage drops. So depending on where you measure it, you could have different voltage, and all those will add up to what the battery equals. For the most part, we've been just dealing with one resistor, so the voltage drop here and the voltage drop here should have been the same because there's only the one resistor. When we had the example, when we had two resistors, we would have a larger voltage drop, and then those two would add together to be whatever the battery or power source voltage was. Resistance, same thing. Add up all the resistors. Resistor 1, resistor 2, resistor 3, however many they are, add them together. And then the current, this is the same for the whole thing. So this follows Ohm's law. Battery divided by the voltage divided by resistance gives you your current. So as long as you have the total voltage or the total current or the total resistance, you should be able to find that using Ohm's law, which you may or may not recall is I equals voltage divided by resistance. How sweet it is to be in Ohm's law. So big thing here is the number of resistors increases, the current decreases. Current is impeded by having more resistance. So the more resistance you have, the less electricity can go throughout the whole system. So current goes down and down and down and down and down. Alright, so let's give this a shot. So I have a circuit here, and we have something called an RVIP chart. Basically what that is a fun way of putting all of your information into a one spot. It's the one spot shop for info, answers. And when I said it's fun, it's not really that fun, especially to grade. So please write clearly, if possible. Alright, so we're looking at this, and we want to know the resistance as each one of these. So we'll start off with the resistance. That one should be easy. It's given to you in the problem. Resistor 1, 25, 50, and 100. And these are all measured in ohms. Sweet. Resistance total. We're going to add all of them together. So 100 plus 50 plus 25, we should end up with 175. Voltage, on the other hand, we only know the total. The total is 120. That's measured in volts. We don't know anything else. We don't know the voltage across 1, 2, or 3, but we can find it. And I'm going to show you the quick way to find it. So in order to do that, what you need to do first is figure out current using Ohm's law. So we're going to take our voltage, 120, divided by 175, and that'll give us our current, which should be roughly 0.686. Now the thing about current is current equals current equals current. So, just like before, once you find your total current, you are set to go. So, this is all 0.686, 0.686, 0.686. Yes! Thank you very much. So now, we can figure out the voltage across each one of these. So by rearranging Ohm's law to solve for voltage, so here's Ohm's law. We can now use our current and our resistance to fill in our voltage drops. So 17 point, I'll round this to 1.5, 34.3, and 68.6. And then if you were to add all of those together, it equals 120, or in this case, 120.05. When it comes to power, what you're going to want to do is take your power equation from before, and you can use any variation that you want from this. You can use I times V, you can do V squared over R. I times V, since you have I and you have voltage, seems like the logical step, so that's what I'm going to do. And that's measured in watts. So 0.68 times 17.15. .06, and total is 82.3. And again, those add up to be all of our power. That's measured in amps. Alright, tune in later for the next version, which is parallel. Remember, that's 9.4 feet. Okay? Hasta luego.